We're about to get risky. This is for my programmers and system integrator friends, people that are building things based on new stuff. RISC V is getting interesting. This is a HiFive Premier P550. Yeah, this is RISC V. It's another RISC V development board. 16 gigs of memory available in a 16 and a 32 gig configuration. This product is so new that a lot of the cool hardware in it, the software hasn't been written yet. You could change the course of history by writing the drivers for this. Alright, so what you get in the box is the board, a Cat 7 cable, an HDMI cable, a USB Type A to USB Type A cable, this is a funky one, and a USB Type A to Type C cable. And then some mounting standoffs for mounting a module on it. And also the I/O shield. So this is the motherboard, this is the module. So basically, you buy this platform and you develop for RISC V with the intention of you're going to deploy RISC V in your solution. You probably don't need a PC motherboard. You can probably do your own low-cost PCB that uses this connector, and then you add these modules. This is a kind of the design manufacturing thing of the future. This is one of the reasons why Raspberry Pis became so popular, is because they've had a standardized I/O interface since time immemorial. And then they switched to the compute module, and now everybody's building compute module stuff around the Raspberry Pi. This is the same kind of thing. We also see this with NVIDIA's Jetson. So like Jetson, it's like, oh, we're going to commit to this platform for 10 years because people are building commercial products around it. Well, this is your opportunity to build commercial products around RISC V, which has a lot of advantages when it comes to royalties and intellectual property and that sort of thing. That's why this thing's so popular. So you got a SATA port, 4-pin fan headers, 20-pin USB 5 gigabit, all the stuff that you would expect from a PC platform. You got your E key, M.2 for Wi-Fi. You got an X16 physical slot, that's X4 electrical, PCIe Gen 3, and all sorts of other connectors on the motherboard, including a CMOS battery port. It doesn't ship with that because international shipping is like, oh, lithium batteries like to catch on fire. But the regulations were written by people too dumb to understand that that kind of lithium battery does not catch on fire. It's the lithium battery that's in like a mobile phone. They didn't write it correctly, and so we're in this mess where we can't even ship little 3-volt CMOS batteries without having the lithium battery disclaimer. We've also got 3 RJ45 connections. 2 of them are part of the RISC V solution. The other one is actually for out-of-band management. So this is a very nascent out-of-band management capability, but you can remote into it and do a whole bunch of stuff with it. There's a micro SD card slot, HDMI, 2 5 gigabit Type A ports. You've also got your basic audio and a Type C port. This takes standard 24-pin power, but you can also run it off of DC directly. There's a big giant switch there that helps you pick. And there's also a secret Type C port for the front as well. There's actually no documentation with it. You have to look it up on the internet. Presumably you will have read every scrap of info about this on the internet before ordering it. Oh, how could I forget JTAG? You got your in-system debugging header as well. So again, development platform, full fat development platform. And since the other RISC V platforms that I've reviewed previously, this is a full head and shoulders upgrade. This is not an incremental upgrade. We actually have out of order execution now, which is a big deal. As the name implies, we've got a new processor, the P550. It's a quad core running at 1.4 gigahertz. Specifically, it's the SWIN EIC 7700X SoC. So 64-bit out-of-order CPU cluster. It has exceptional performance in the RISC V family flexibility and enables developers to create high-performance RISC V applications and bring their projects to life, so it says on the website. 16 gigs of Micron LPDDR5. That's running at 6400, believe it or not. That's just very impressive. Full-featured PCIO, and it's got Ubuntu 24.04 LTS pre-installed, which is based on a 6.6 kernel. The GPU is an AXM A256 onboard GPU, and the GPU hardware does actually support hardware acceleration for video encoding up to 8K at 25 FPS, 8K at 50 FPS for hardware accelerated decoding, and there's a hardware accelerated AI NPU with 20 trillion int8 operations per second. Now, the encoder and the decoder and the AI coprocessor, there's no software yet, at least in February of 2025. If you follow GitHub, there's a couple people that look like they're banging on support for this, but this board literally just came out. So this is a fast changing landscape. And like I say, if you're considering RISC V for, like, say, a network video conferencing product or something like that, and you need the encoding, chances are, as part of your day job building that thing, you're going to get the time to be able to do that. The other wrinkle with that is, like, is there intellectual property controls, or is there any, like, I can't just implement the hardware. There may be, like, software controls or software licensing considerations to worry about depending on the particular codec that you're using. And so some of that hasn't been worked out yet, but by and large, some of the codecs are supposed to be royalty free. So again, the particulars of that is going to depend on the implementation and the specific problem that you're actually trying to solve. But still, exciting times. And just so you don't get the wrong idea, this really is meant to be an embedded development platform. This isn't meant to be a low-cost workstation or a low-cost mini PC or something that you would build an earnest workstation for. This is for, gearheads, propeller heads, super nerds to experiment with and build something on and just see how things go. You would use something like this in maybe a small networkable appliance. So you've got, 2 1 gigabit network ports. You could build network attached storage from that, an inexpensive network attached storage device. You got 4 Gen 3 lanes, so you could take that out to some other peripheral. There's lots and lots of embedded systems that you could build around a processor that's this powerful, relatively speaking, of course. But this is not meant to be even something that is more powerful than, like, the Raspberry Pi 5 at this point. But they're getting there. Eventually, someday, maybe possibly, they're going to get there. So I think what I'd like to do, if you're interested in RISC V and you want to do something with this, hit me up in the forum. I can probably set you up with remote access to this to run some benchmarks or do some testing or something like that. I'll add some small SATA storage to this, get it on the network, get it isolated on the network, and then let you poke around with it and see, like, give me a proposal, let me know, and yeah, let's see. And who knows, I might do a giveaway. I've got a couple of the older RISC V boards, and maybe if you do an interesting project and the community really latches on, or you want to just do something neat, then yeah, that would be something interesting. But for now, this is just a quick unboxing of the P550, and wanted to talk about the whole, it's like, oh, they finally got out of order execution. Woo! Runs Linux out of the box. What more do you need? I'm Wendell, this is Level 1. I'm signing out. You can find me in the Level 1 forums.